Welcome to the DIY Honda Garage channel. In this presentation, we will focus on diagnosing the DTC code P0532, which indicates a low voltage condition in the AC pressure sensor circuit. This error is relevant for the Honda Pilot models from 2016 to 2022. The AC pressure sensor plays a crucial role in the vehicle's air conditioning system by monitoring the refrigerant pressure and sending this information to the powertrain control module, PCM. A low voltage condition can affect the functionality of the air conditioning system, potentially leading to inadequate cooling performance or system failure. Our goal is to systematically troubleshoot this DTC in a structured manner, ensuring that each component is thoroughly checked for functionality. The DTC P0532 specifically points out a low voltage issue within the AC pressure sensor circuit. The AC pressure sensor is essential in monitoring the refrigerant pressure in the air conditioning system, relaying necessary data to the powertrain control module, or PCM. Its location is generally situated near the AC compressor, which is responsible for compressing the refrigerant in the cooling cycle. When the pressure sensor circuit experiences low voltage readings, it may trigger the DTC P0532, disrupting the AC system's performance. This low voltage indicates that the sensor might not be supplying accurate pressure readings, which can lead to improper functioning of the air conditioning system, such as failure to cool effectively. Understanding the role and location of the AC pressure sensor is crucial for accurate identification and resolution of this error. Several potential causes could lead to the DTC P0532 being triggered. One likely cause is a faulty AC pressure sensor, which may fail to generate the correct voltage readings. Alternatively, loose connections at the sensor or within the circuit can result in low voltage signals reaching the PCM, thus leading to the error code. Wiring issues such as broken or shorted wires in the circuit can also contribute to the low voltage condition and should be carefully examined. Additionally, problems with the PCM itself can arise, perhaps affecting the circuit's performance and leading to erroneous voltage readings. Inspecting all these components is essential for accurate diagnosis and repair. When the DTC P0532 is triggered, several symptoms may be evident. One of the most noticeable symptoms is that the air conditioning system may not cool properly, affecting overall passenger comfort. Additionally, the illumination of the check engine light or AC system warning light on the dashboard can be expected, alerting the driver to an existing issue. You may also notice poor air circulation from the vents, indicating that the system may not be functioning as intended. These symptoms are critical, as they not only affect the comfort of the passengers, but also indicate that further investigation is required to resolve the underlying issue associated with the AC system. In the first troubleshooting step for DTC P0532, begin by starting the engine and letting it idle. Once the engine is running, turn the blower switch on to ensure that the ventilating system is active. Subsequently, you'll want to activate the air conditioning by turning the AC switch on. At this point, it's crucial to check the parameters using the Honda Diagnostic System HDS tool. You will specifically check the AC pressure sensor readings to ascertain if they are below the established threshold of 0.24 volts. If the current conditions match the threshold indicating low voltage, the failure has been duplicated and you will proceed to the next troubleshooting step. If not, you may need to check for intermittent failures or poor connections in the circuit. This verification process is vital to ensure that we are addressing the correct issue. Proceeding to the second troubleshooting step, turn the vehicle off to reset the system. After the vehicle has been turned off, disconnect the AC pressure sensor by removing the 3-pin connector. It's important to ensure that the vehicle is completely off before making this connection change to prevent electrical malfunctions. Next, Turn the vehicle back to the on mode without starting the engine. Utilizing the HDS tool again, check the parameters of the AC pressure sensor once more. Specifically, you're looking to see if the readings continue to reflect a low voltage condition. Again, confirming whether they are below the 0.24 volt threshold. If they do match this threshold, continue to the next step in the troubleshooting guide, as this indicates a potential issue further along the circuit. Otherwise, further investigation into loose connections or intermittent failures is recommended. In this third step, your objective is to measure the voltage across specific test points in the AC pressure sensor circuit. Ensure the vehicle is in the on mode while keeping the AC pressure sensor 3P connector disconnected. You'll utilize a multimeter to examine the voltage between test point 1, which corresponds to pin 1 of the female terminals of the AC pressure sensor 3P connector, and test point 2, which is pin 3. It is crucial to check for a voltage reading of approximately 5.0 volts. If you find that the voltage reading aligns with the expected value, this indicates that the circuit is likely functioning correctly and leads to the conclusion that the AC pressure sensor may need to be replaced. If the voltage reading does not match the necessary output, proceed to check for other issues as directed in the troubleshooting procedure. For the fourth troubleshooting step, ensure the vehicle is turned off before starting any further checks. You will need to jump the SCS line while using the Honda Diagnostic System, HDS, to enable special diagnostic functions. Once this is completed, disconnect the PCM connector E, which is typically an 80-pin connector. Following this, you will check for continuity between specific test points. Pin 3 of the AC pressure sensor 3P connector and pin 76 of the PCM connector E. Conduct this continuity test to ensure there are no breaks in the wiring. If continuity exists, this indicates that the VCC2, VCC6 wire is functioning properly, prompting the need to review any authorized service information related to the DTCs as well as potential issues within the PCM. If continuity is lacking, however, this means an open circuit exists within the wire and requires immediate repairs. In the fifth and final troubleshooting step, begin by ensuring the vehicle is turned off. Similar to previous steps, jump the SCS line with the HDS tool. Afterward, disconnect the PCM connector E, which houses multiple pins that communicate with the AC pressure sensor. At this point, you will conduct another continuity check. This time, it involves checking between pin 2 of the AC pressure sensor and the vehicle's body ground. A successful continuity test would indicate a short in the ACPD or PD sensor wiring. If continuity is found, repairs must be made to address the shorted wire. Conversely, if there is no continuity, the wiring may be intact, and further diagnostics should be conducted, including possibly substituting a known good PCM to see if the DTC P0532 clears, indicating that the original PCM was at fault. After completing the necessary repairs associated with DTC P0532, it's crucial to perform a final verification to ensure that the issue has been resolved. Start by clearing all DTC codes using the HDS tool, which allows the system to reset and eliminate any stored error codes. Following this, you should test the operation of the AC system to ensure that it functions correctly and provides adequate cooling performance. Observe the system to ensure that it operates smoothly and monitor the AC pressure sensor's readings. Finally, you must verify that the DTC does not return upon rescanning with the HDS tool. This comprehensive approach to repair and verification helps ensure the vehicle is operating correctly and confirms that the troubleshooting steps were effective. preventive maintenance plays a crucial role in sidestepping future issues related to DTC P0532 and overall AC system performance. Regular inspections of the AC system components are essential. This includes checking for any visible signs of wear or damage, as well as ensuring that all electrical connections are secure and tight. Additionally, monitoring the wiring for any potential frays, corrosion, or loose fittings can help avoid any low voltage issues. Keeping the refrigerant levels within the manufacturer's specified limits is equally important, as incorrect refrigerant levels can also lead to abnormal pressure readings, ultimately triggering error codes. By implementing these preventative measures, you can maintain the system's reliability and functionality while reducing the likelihood of encountering this DTC again. In conclusion, effective diagnosis and repair of DTC P0532 involve identifying specific issues with the AC pressure sensor circuit and implementing a systematic troubleshooting process. Whether addressing faulty sensors, loose connections, or wiring issues, each step provides critical insights into maintaining the vehicle's air conditioning performance. Regular maintenance practices, including thorough inspections and proper refrigerant management, can significantly reduce the risk of P0532 and enhance the overall functionality of the AC system. It's essential to be diligent in both troubleshooting and preventive maintenance to ensure a reliable and comfortable driving experience in your Honda Pilot from 2016 to 2022. Please like and subscribe to the channel. See you next time.